Hi everyone, good evening, good evening, good evening. Are we live? क्या मैं लाइव आ चुकी हूँ? जल्दी से बता दीजिए. A very good evening to all of you. I hope आप सब बढ़िया, एकदम मस्त, एकदम ढिंचैक. Yes everyone. Hi everyone. Good evening. कैसे हैं आप सब लोग? How are you all guys? I hope all are doing fine. So B2A series में today we have the next session in which we are talking about the rise of quantum theory, quantum mechanical theory. In the last session we did Bohr's model. I hope you all did that guys. Yes, Bohr's model guys. Have you all did that? Bohr's model. Very important for your junior science Olympiad. So if you are done with the Bohr's model, this is something really interesting and important for you all. That is the rise of quantum theory. Yups, guys. Yes. Okay. I hope I'm audible, visible. जल्दी से बता दीजिए कि क्या आप मुझे देख पा रहे हो, सुन पा रहे हो. Are we live? So that I can start today's session. That is quantum mechanical theory. How the quantum mechanical theory came into the picture, right? Yes. Okay, great guys. So before starting anything, just a simple thing I want to share with you all, because you are also targeting junior science Olympiad. I'm sure you are targeting NSEJS 2025, so you can take inspiration from the students who created history. So these are our fantabulous results of INJ, so the second stage of junior science Olympiad, and INJAO, that is Junior Astronomy Olympiad. You can see 20% selection. And let me again tell you that for Junior Astronomy Olympiad, you have to give NSEJS exam only. Even if you are interested in Junior Astronomy Olympiad, you are supposed to give NSEJS, because the first stage is common for both. In fact, the second stage is also common for both Junior Astronomy as well as Junior Science Olympiad. Right? Yep. So guys, I hope these are the results that you are aware of already. And something really exciting is coming up for you all. So if you love science, right? So there is something really big, really important, a big reveal is coming up for you. So you can check out the link in the description box, a big reveal, but for only those who love science, who enjoy science, who want to learn and explore the mysteries of science. Yep. Yes, Shreya Mishra. So just follow the series. This series, we will have a good foundation for our JEE exam, right? Okay, guys. So in the last, session, we did Bohr model, which was based on Max Planck quantum theory, in which he said, okay, guys, that light has dual behavior. Light, which was considered as a wave, Planck proved that it has a particle nature also, and the same particle nature was used by Einstein and Bohr to explain the phenomena and the models. So your light, which is considered to be a wave, is also having a particle-like behavior. Now what about electron? Electron, whenever I say electron, you all think it to be a particle, right? One particle, that is electron. So we all by default assume electron is a particle. But again, there is a twist. It is not just a particle. Nature loves symmetry. If your wave, that is light, behaves like a particle, so your particle, that is electron, must also behave like a wave. This is what de Broglie, the famous scientist de Broglie, thought, that nature loves symmetry, right? So if light is a particle also, so a particle electron should also have a wave nature, right? So that means there is a duality in the behavior of matter. Matter has a dual nature. It has a particle nature as well as a wave nature. This concept changed the entire course of atomic models, because till now, till Bohr's atomic model, Sommerfeld atomic model, electron was considered as a particle. Nobody ever thought of electron as a wave, so they never included the wave nature of electron in their atomic models. So all of a sudden, this new concept came up which told everyone that electron also has a wave nature. So it is a wave that changed the entire future ahead, and the credit goes to, yes, the credit goes to very own de Broglie, right? So what is de Broglie's concept or de Broglie's hypothesis, right? So according to de Broglie, nature loves symmetry. Yes. So if your light has a particle nature, in the same manner, your particle should also have a wave nature. They should have wavelength. They show characteristics like a wave. So if I have this marker in my hand, which is assumed to be a particle, an object, but it is also having a wave nature, it has a wavelength, right? Yes, surprising. Ball, football, they are particle in motion. They should also have a wave nature, and the waves associated with matter are known as matter waves, right? So this concept was introduced by de Broglie that your matter has dual nature. It has a particle nature as well as wave nature, right? So wave associated with matter, they are known as matter waves. Hi Tanmay. Yes. Matter waves and the wavelength associated with them, we call it as a de Broglie wavelength, right? So everything has dual nature, right? It has a particle nature as well as a wave nature. Slowly and steadily it will start making sense. So de Broglie gave the formula for the wavelength of matter waves. What is a matter wave? The waves nature associated with any matter, football, ball, pen, marker. If you are moving, you have certain wavelength. So the wavelength is associated with matter waves is h by p. H is Planck's constant, p is momentum, so h by mv. This is the formula for matter waves. So according to de Broglie, your electron, which was considered as a particle, is also having wave nature. Hence, it has a wavelength which you can calculate using the same formula. So again, if you have a football or a cricket ball having mass m moving with velocity v, it is also having wavelength associated with it because it is also having wave nature, right? So again, you can use the same formula, the de Broglie's wavelength formula, to calculate the wavelength of moving football or electron. Got it, guys? Yes. So here comes electron is a wave, right? Right? And you know what the interesting part is? I hope you all know who discovered electron. Who discovered electron? If anyone of you know, please write in the chat box who discovered electron. Electron was discovered by J.J. Thomson, a famous scientist, and he discovered electron and proved them to be a particle in cathode ray experiment. And the interesting part is his son, G.P. Thomson. He also got the Nobel Prize in Physics for proving electron has a wave nature. So you can see the beauty of science. Father got the Nobel Prize for the discovery of electron, proving them as particles. Years later, his own son proved that electron also has a wave nature and got Nobel Prize for the same. Yes. Okay. So guys, this is the formula. Lambda is equal to h by mv. Those who are preparing for Junior Science Olympiad, please take a note of this formula, guys. Lambda is equal to h by mv. M is the mass of the particle. V is the velocity of particle in meters per second. P is the, of course, momentum. So now the question is, if the mass of the particle, you can see I have electron, I have a cricket ball, both are moving with the same velocity. Cricket ball as well as electron, both are moving with the same velocity. So V is same for both. Now I can say in that case, because H is also constant, that is Planck's constant only. So I can say in that case, more is the mass of the particle, lesser is the wavelength, its wavelength, yes. So out of electron and a cricket ball, because electron being a microscopic particle, it is very small, its mass is negligible. So the wavelength associated with that moving electron is significant. Lesser mass, more wavelength. Whereas the mass of cricket ball, because that is a part of this macroscopic world. So your cricket ball being more in mass, the wavelength associated with that cricket ball is less. And that wavelength is that much low that it is kind of negligible in this macroscopic world. Right? When I talk about electron, atom, I am talking about microscopic world. That wavelength plays an important role because it is significant in that microscopic arena. Whereas the wavelength which is associated with the macroscopic object, a heavy object, that comes out to be less, and that value is negligible in this big huge universe, the macroscopic world. Right? Yes. If I am moving, I also have wavelength. If football is coming, that is also having wavelength. Everything in motion is having a wavelength, but what matters is whether it is significant or insignificant, negligible or not. So whenever we talk about atom, electron, the microscopic particle, their mass is less, so their wavelength is significant in that microscopic world. Whereas if we talk about macroscopic objects, because they have more mass, so the wavelength comes out to be lesser value, and that less value is almost insignificant, has no value in this macroscopic world where the dimensions are more. Got it? So there is a duality. Particle behaves like a wave, wave behaves like a particle. Right? So this concept of de Broglie, as I told you, changed the future course of action of all atomic models, because till now nobody thought of electron as a wave. Every model is J.J. Thomson, Rutherford's atomic model, Bohr atomic model, they all considered as a particle. Now scientists got a different direction. Oh my God, electron is a wave and its wave nature is dominating. So we should also consider that wave nature of electron. Then only we can, then only we can understand exactly how an atom looks like. Yes? Yes, Daksh. So we are having these sessions for Junior Science Olympiad. So whenever I say Junior Science Olympiad, the syllabus is more or less the JEE and the NEET syllabus. So whenever we teach to a class 8, 9, 10 student under the cover of Junior Science Olympiad, NSEJS exam, that means we are teaching them the concepts of to the level of JEE Mains and NEET, right? Okay. So interesting, right? Now all the future models will consider electron as a wave. So there's a common, viral phrase, na? Bhavnaएं बदल गई, जज्बात बदल गए. So the same thing happened with the scientist. They got this realization, oh, electron is a wave. So all the future models, the base of quantum mechanics, the quantum mechanical model is based on this fact, considering electron has a wave nature. Yes? Got it? So guys, as I say, the wave character of larger object has no practical significance because their wavelength is too small in this macroscopic world, the world of measurement. Whereas when I talk about the small particles in motion, the microscopic particles, because their mass is less, so they have significant value of wavelength in their microscopic world. Right? Yes, so using the same formula, can you please calculate the de Broglie wavelength of a cricket ball? Mass is given to you. Use the SI units, guys, while using the formula. So speed is lambda is equal to h by mv. Right? So because we are calculating here, the options are given in centimeters. So you can use the CGS system. Right? And Planck's constant value is given to you. Mass you can use in grams in CGS system. Velocity is also given to you, centimeters per second. So use this value and let me know what is the, wavelength associated with that cricket ball. Quickly, let's see how many of you can give me the right answer, guys. Solve, be quick, guys. And questions have been, the junior science Olympiad have been asking questions on de Broglie concept in various stages. Be it first stage NSEJS, be it the second stage INJS, so be it the last stage International Junior Science Olympiad. Okay, so Logic Explorer and Tanmay Kathuria. Direct application, so the wavelength associated with the cricket ball is indeed a direct application of formula, nothing else, right? You can check the calculations, be mindful while calculating. Now, so basically, let me tell you more. So suppose, as I told you the formula, right? So I told you the formula lambda is equal to H by mv. And kinetic energy, I hope you all know kinetic energy is half mv square. So I can write the formula for this. Can I change the formula multiplying the, so let me 2 ke by m, that is equal to v square, or I can write v is equal to under root of 2 ke by m, right? So this is the formula. Putting this formula here, I get lambda is equal to h over under root of 2 ke, that kinetic energy, into m. So if kinetic energy of the particle is given, you can directly use this formula, another form of the same formula, h by under root of 2 ke, that is kinetic energy, into m, right? And also if you have charge q accelerating through a potential difference of v volts, if you have charge q accelerating through a potential difference of v volts, its kinetic energy, I hope you know, is qv. So for a charge q, be it electron, be it proton, any charged particle, be it alpha particle, you can use this formula under root of kinetic energy. You can put qv, v is the volts, guys, potential difference, to m, right? So these are the various forms of the same formula depending upon the data given in the question, whether they are giving you the kinetic energy value, whether they are talking about a charge accelerating through a potential difference of v volts. You can use the formula to calculate the de Broglie's wavelength. Yes, done. Please see. So v is under root of 2 ke by m. Done. Put the value, you will get to know. Yes, Tanmay? Okay, so all these formulas you should know. You can use depending upon the numerical given to you guys, right? And the same formulas, the question directly on the same formulas are being continuously asked in JEE Mains and NEET exam. Got it? So anyone who is aspiring the top ranks in JEE and NEET presented in class 9th and 10th, please take care of these formulas. Entire JSO syllabus is very much aligned with your JEE Mains or the NEET preparation. Okay, so guys, I have told you about the de Broglie's concept. Now the world knows electron has a wave nature. Yes. What registration about this exam? Shreyash, the exam registration will begin in August. So do not worry. Exam will be in November. Registration will start in August. Heisenberg's uncertainty principle. Another important person who laid the foundation of the modern models is Heisenberg. Considering the fact, as told by de Broglie, that electron has a wave nature, Heisenberg said, if electron is a wave, guys, forget that you can calculate its position and its velocity simultaneously with accuracy. So Heisenberg declared whatever you are trying to do is not possible. So as per Heisenberg, because electron is a wave, right, the position and the momentum, or you can say the velocity, the position and the momentum of a microscopic particle, cannot be known or calculated exactly with accuracy. It is impossible to measure the position and momentum of a microscopic particle like electron simultaneously with accuracy, right? So if the electron is there inside an atom, of course it is moving. Either exactly you can tell its position or its momentum, both at the same time, both accurately you can't tell. That right now at this point the electron is here moving with this velocity. There is always some doubt, error in the or the uncertainty in the values. So the statement says it is impossible to measure simultaneously. Please emphasize is on word simultaneously and precisely or accurately both the position and momentum of a microscopic particle. You can't measure both of them accurately simultaneously. There is always some error in one of the two values. If one you can be 100% correct, then there will be error, infinite error in the another value. So yes, interesting meme on the same. Yo. So Werner Heisenberg is driving down the highway and gets pulled over by a cop. The cop says, do you know how fast you are going? Heisenberg says, no, but I know exactly where I am. I don't know my speed, I don't know my velocity, but I know my position. Because if I can tell my position exactly, I can't be certain, 100% sure about my velocity. Right? So, it's a sine wave, no? It's a sine wave. I hope you know the sine wave. Yes, yes, of course. Yes, Aryan. So, he gave this formula, right? That delta x into delta p is always greater than equal to h by 4 pi. What is delta x? The uncertainty in position, the doubt, the error. What is delta p? Delta p is uncertainty, or you can write it as m delta v, right? Delta p is uncertainty in momentum or the error in momentum, or delta v is the uncertainty in velocity, right? So guys, basically it's delta x, delta v or delta p. So it is the error, the uncertainty. Suppose, and you all, like most of you are having your school exams. After your school exams, if somebody asks, your parents ask, your mom asks, how was your exam? So you say, okay, it was good. So if somebody asks, how much you'll score, any idea? So what you'll say? Out of 100, I'll score, it can be, 95 plus minus 2. That uncertainty is plus minus 2. It can be 95 plus 2, it can be 95 minus 2. So that delta, the uncertainty in the marks is that plus minus 2 value. The 2 value is the uncertainty in the marks, right? So same here in this formula, delta x is the uncertainty, the doubt in the position. Delta p is the uncertainty in momentum. Delta v is the uncertainty in velocity, right? For solving numericals, we take it as delta x into delta p equal to, we take it as equality, h by 4 pi, right guys? So we take it as equal, we don't take the inequality. Got it? Yo? Done? So I can also write it as delta x into m delta v is equal to h, again our very famous Planck's constant, right? A constant value. These are the formulas that you'll be using to calculate the numericals, right? Yes. Now let's try to understand. So suppose I want to see the exact position of my electron. This is the atom. I want to see the exact position of my electron. So what I'll do? I'll use a microscope, electronic microscope. I am using a microscope, and in microscope, in the instruments, we use light. Light has photons, the quantas, the packets of energy. So for looking at that electron inside an atom, I am using, what I'm using? I'm using a microscope. In that we have a light. There are the certain principles of optics, right? It is working on. So when I use the light to see that electron, what happens? That light which is having photons, that will hit your electron, which is a microscopic particle. so that can change its path or velocity. So it is not possible to measure both the position and the velocity of a microscopic particle like electron simultaneously, ek saath, with accuracy. Right? Yes. So guys, this is Heisenberg uncertainty principle. Now think about it, guys. Two main concepts came before the final quantum mechanical model, right? Two main concepts came. One is de Broglie's concept, which says electron has a wave nature as well. And on the top of it, we have Heisenberg's uncertainty principle that says, what it says? Guys, you can't measure the position of electron and its velocity exactly accurately at the same time. Do you remember Bohr model? In Bohr model, Bohr said the electrons are in a fixed circular path. So you know the path where it is revolving. And you have the formulas for the velocity of that moving electron, for the radius of orbit. So according to Bohr, you can calculate exact velocity of that moving electron, how far it is from nucleus, that radius also you can calculate. But these two theories that contradicts Bohr's model, the postulates of Bohr model, right? First of all, electron is not just a particle, it also has a wave nature which is significant, and you can't tell both position and velocity of the moving electron in the atom exactly accurately, right? Got it, guys? So let's move ahead. Let's do a numerical. Let's see how many of you can give the right answer without committing any calculation mistake. Let's see. Calculate the uncertainty in velocity delta V you are supposed to calculate. So delta V you are supposed to calculate. The mass. So formula is delta X into M. The mass is given delta V H by 4 pi. Right. So what all is given to you, guys? The mass is given to you. The uncertainty in position, please take the SI unit. So it will be 10 raised to power minus 10 meters. kg, 150 into 10 raised to power minus 3 kg. Put these value, Planck's constant, you already know, values also given. You can calculate delta V, the error, the doubt in its velocity. Yes, RN Yadav, you want to purchase book for which exam? Yes. If you want to purchase book for Junior Science Olympiad, I will suggest buy the practice book, question practice book. And if you want to buy a book, chemistry book for theory, as per your future target, if you are a JEE aspirant or a NEET aspirant, you can buy those books, JEE or NEET books, the famous books. For chemistry, you can, for solving, you have N. Avasthi, right? Neeraj Kumar. Both for NEET and JEE you have N. Avasthi, you can take up any. For theory, you can buy Cengage for physical chemistry. For inorganic, you can buy the J.D. Lee. So I am suggesting those books that you can use for your JEE or NEET preparation also. So if you are buying a particular subject book, not a practice question book, so go for JEE books or NEET books, whatever you are going to opt in the future. Right? Because the same books you can use now, you can use for your JEE preparation. So it's better, save money, use the books. Okay, JEE Hustler, Logic Explorer. Okay, the option is A. Let's check it out. Is it A? Indeed, it is A. Right? So guys, these two important concepts laid a foundation of a new branch of science, that is quantum mechanics. There is another person, Schrödinger, who contributed a lot to establish this new branch of science that we call quantum mechanics, leading to a new model, the final model, that is quantum mechanical model, the probability based model of an atom. Right? Yes. So these two theories laid the foundation. What is quantum mechanics? The branch of science which studies the particle in motion, the microscopic particle in motion, right? Which are not following the usual laws of physics, the laws of motion, right? Yups. So quantum mechanics, honestly, one of my favorite topics, same JEE Hustler. and the most interesting part of chemistry and physics, because quantum mechanics is science, basically a branch of science. So you can consider it as a part of physics, you can consider it as a part of chemistry, and it is full of maths, higher level maths. So it is indeed a part of maths. You know, double differential equations, that is there. You solve double differential equation, get the solutions. So basically this quantum mechanical branch of science is theoretical. Theory, you're not doing any experiment to prove anything. You are proving the biggest and the biggest mysteries of the atomic world by using mathematical calculation, the phenomena, the physics. You are proving, hence proved, sort of, right? As we do some derivation in maths, hence proved. So in the same way, you prove things in quantum mechanics by considering a situation, by plotting graph, by solving higher order mathematical equations. So that is quantum mechanics. And the quantum mechanics give our final model, that is quantum mechanical model. And huge credit goes to, of course, Schrödinger. So he gave a wave equation to explain the motion of electron in an atom. A mathematical equation which is double differential equation. That double differential equation explains, defines the motion of an electron inside an atom. Right? So that is Schrödinger's wave equation. Okay, so in the upcoming sessions, we'll be doing this new model which talks about the probability, which is based on quantum mechanics, the quantum mechanical model, and the most interesting and the final model of atom. Right? Yes, bilkul, perfecto. So this is a homework question for you all. And if you love science, so please note the homework question and do write me the answer in the chat box. It is also a PYQ, JEE PYQ, guys. Right? And if you love science, something big is coming up for you. Right? If you are a lover of science, if science excites you, the curiosity that you have, you want to know the reason behind everything, why it is happening, how it is happening. This is what science is now. If you want to evolve a scientific aptitude, if you want to think like a scientist, something really big is coming for all the science lovers of the world, not just India. जहां भी हो, जब भी हो, जैसे भी हो, अगर तुम्हें साइंस पसंद है, this is for you. Right? Yes. So आपको वीडियो के डिस्क्रिप्शन बॉक्स में लिंक मिलेगा, जाइए देखिए क्या है और क्या आने वाला है इस वीक. Right? Okay guys, bye, take care. Hi Joyran, take care, God bless you all. I hope आप enjoy कर रहे हो साइंस को, irrespective of your grade. That is most important यार. तुम्हें साइंस में मजा आएगा तो ये एग्जाम से तुम वैसे ही क्रैक कर लोगे, चाहे वो साइंस ओलंपियाड है, जेई है, नीट है, या तुम्हारा सपना किसी आईवी लीग कॉलेज में पढ़ने का है, माइट स्टैनफोर्ड जाने का है. सो दीज ऑल थिंग्स यू विल डू. सबसे इंपॉर्टेंट है साइंस में मजा आना चाहिए. दैट क्यूरियोसिटी, दैट थिंकिंग, हाउ टू थिंक, हाउ टू क्रैक द कोड, वो आना बहुत जरूरी है. राइट? बाय, टेक केयर, गॉड ब्लेस यू ऑल. पढ़ते रहो, बढ़ते रहो, मचाते रहो, देश को गोल जिताते रहो. कीप लर्निंग, कीप ग्रोइंग गाइस. बाय, टेक केयर.